All right, in this video, I'm going to finish the section 1-2 dealing with using estimation to get information from graphs. All right, so we had done most of this, but we were left with just two types of graphs. We had done the bar charts, but then a pie chart, circle graph, pie graph, is constructed by drawing a circle, and then you cut it into parts that represent the relative proportion of each item to the whole. So for instance, in this one, we have military spending by country. So take a moment to look at that. And you can see the United States, it shows the United States spending 39.3% of the total that was spent worldwide. China, 12.7%, and so on. So our job is to estimate how much was spent by the U.S. and how much was spent by Russia, is what we're being asked for. So for the U.S., we know they spent 39.3% of the total amount, which was $1,981 billion. Now, this one says use estimation. So typically I would say, you know, you could round the 1981 to maybe 2,000 billion and maybe round 39.3% to 39%. But really, it's almost like those are estimates already. They really intend for you just to change the 39.3 to a decimal and multiply it by 1981. Remember, it's in billions, it's $1 billion. And then round the answer at the end. So go to your calculator and do that. When you're changing a percent to a decimal, 39%, this percent means divide by 100. So that's why it becomes 0.393. Multiply that by 1981, and we get 778.533, and that would be $1 billion. All right, and estimate how much, so we might round that to 779 billion. Now they might ask for a specific, like round to the nearest tenth or something like that. If they did, I would have rounded it to 778.5 billion if they said nearest tenth. Okay. All right, so that's for the U.S. So they want us to do that for Russia as well. I was kind of surprised by this. So with Russia, it says they spend 3.1% of the total. So I'm going to change that. Now notice when you divide by 100, that's like moving the decimal two places. So I'm going to move the decimal two places. And then I'm going to take that 0.031 times the 1981 billion. Okay, so go to your calculator and do that while I'm doing it. And I get 61.411 billion. So if I rounded to the nearest whole, that would be like $61 billion. If I rounded to the nearest tenth, that would be $61.4 billion. Okay. All right, and that's a pie chart when you have those little circles that are then subdivided into sectors where the size of the sector implies how much of the whole that portion turns out to be. All right, one more type of graph I'm going to look at is this kind, sometimes called a line graph or a time series graph. Okay, so both of these graphs are actually the same exact data, but it has a very different feel to it, but it's the same data. This is trying to make the point that you need to kind of be careful about the scale on a graph, because this one here kind of exaggerates the jumps that you see, because the scale of the graph wasn't from 0 to 48 or 0 to 50. And so it ignored all the way from 0 to 30. It started at 30, where this one starts at 0. So the fluctuations don't look so extreme. So the approximate number of people living in poverty in 2015. We would go to 2015. Now this is hard to do with the way I'm writing on my screen, but I think you can do it better. So you go up until you hit the function, and then you read across, try to be, running over to the left. It looks like less than 45, maybe a little more than halfway. So I might say about 43, and that's in million people. All right, now this would give me the same information. I would go until I hit the function. Oops. I don't know why I did that. Let me start again. I would draw up here until I hit the function, trying to go straight up from 2015, but I'm writing vertically, so it's a little messy. Then I would look across here, and this one I can see it's somewhere between 42 and 43. Looking at that one, I might even have said 43 or 43.5 million even people. Okay, so the data is the same. It's just because of the scale, it has quite a different look. Now, the next question is what is the rate of change at which the number of folks living in poverty changed between 95 and 2000, okay? So for that one, I'm going to go to 95 and estimate what that is. Then I'm going to go to 2000 and estimate what that is. I hate it when they don't give me the raw data so I can double check what I'm doing. Okay, and then let me just see if it's easier to read when I'm over here, since this has a smaller scale. And then 2000. Okay, over there it almost looks like at 1995. On the one on the right, it should be the same on both, almost looks like 36. The one on the left does look like it should be a little above 35, so I might say 36 million people. And then at 2000, they appear to be around 30, maybe a little higher than 30, because you got to try to go parallel. So I would say maybe 32 million. And so do you notice that from 1995 to 2000, okay, that it went down about 4 million in 5 years? Okay, so down 4 million in 5 years. So if we divided the 4 by 5, it would go down 4/5 of a million in 1 year. That's negative 0.8 million per year. Negative meaning it went down, and 0.8 million, let me do it over here, 0.8 million. So million would be tens, hundreds, thousands, 10,000s, 100,000s, millions. So that'd be 800,000 people. Okay, so down about 800,000 people per year is what we wound up with. Okay, and one more question. Let me see if I can scroll down to see what that is. Last question is which of the two third question. Estimate the year in which the number of Americans living in poverty first topped 40 million. So for that one, get rid of what I've already written on these. Okay, doesn't matter which one you use. Okay, so you would go to 40 million and you draw this horizontal line, make it as horizontal as you can until you hit the graph. Let me try it over here and see where I hit the graph. And then you would come down here and try to estimate about when that happens. Or here, come down here and try to estimate about when that happens. Your line should be dropped perfectly perpendicular. So 2005 to 2010, that's 5 years. Notice it doesn't matter which graph, we're going to get it being a little less than halfway to 2010. Halfway would be 2007.5, so maybe 2007, okay, or midway through 2006, something like that. Okay, and then which of the two gives a more accurate view? Probably the first one. It goes from 0. So the changes are not exaggerated.